Hello everyone, welcome to IMS GATE Academy. I hope you guys are doing well. Here in this series, we already started on 1st and 2nd August most expected concept of engineering mathematics, right? Today we will continue the same thing here from the most expected concept of linear algebra. We had a discussion on the concepts related to determinant and inverse. Now in this session we will continue that topic, that specific linear algebra topic or content, and here we will discuss the new topic, which is system of equation, linear system of equation. Acha, before going to that one, in the last class I gave you this question as a homework. So I hope you guys approached it, because in the last session we learned how to find the inverse of a 3x3 matrix in a simpler manner, in a easier manner. So I hope you guys approached it already. Let's start first of all this session with this question, and then we will continue to the linear system of equation, which is today's heading. So if you can hear me, bachcha log, please confirm audio and video both are clear or not. Okay, let's approach it here. So please confirm audio and video both are clear or not. All right. So here let's start with this question. We are having a matrix R, which is a 3x3 matrix, 1 0 minus 1 2 1 minus 1 2 3 2. We need to find out the top row of this matrix R inverse. Okay, so here we are having options how to find out, as we had a discussion on the trick how to find out the inverse of any 3x3 matrix. Bacho, if you will follow this question, if you will approach this question for finding inverse by the conventional method, means if you will follow here adjoint A by determinant of A, if you will find out here the adjoint of each and every element and then you will approach it, then it will be very lengthy. Yeah, good evening, welcome Abhishek, and what's your name? Papa ka pagal son. Okay, Aditya, welcome bachcho. So here we know that if I will follow here that method, then it will be very lengthy, because here I need to go for the cofactor of each and every 9 element here. Then we need to careful with the sign, we need to go for the transpose of that matrix, that will be the adjoint here. Okay, so it will be very lengthy. All right, so let's talk about directly in this question. So we will follow the method for finding the inverse of any 3x3 matrix. What we need to do, I will just write down here the matrix first of all as it is. I will just write down here the matrix. Wait a minute. Okay. All right. So here I will go for the inverse. So how to find out the inverse? Let's approach it, bachcho. I will write down first of all the matrix as it is: 1 0 minus 1 2 1 minus 1. Next is 2 3 and 2. Now what we need to do, we need to write down the first two columns. So it will be 1 0 2 1 2 3, and then we need to write down first two rows also: 1 0 minus 1 1 0. It will be 2 1 minus 1 2 and 1. Now I will leave the first column and first row. Okay, now as in this question, very good, we will leave here the row and column. Yes, so here I can see I need to write down only one thing here. I need to find out top row of R inverse. So I will not approach all the elements, whether I will tell you how to find out this one. So if we need to find out the inverse, I hope you guys remember that R inverse is nothing but adjoint of that matrix divided by determinant of that matrix R. So if I will not find out here determinant, then also it will be work. Why? I will show you. So here I need to find out the adjoint. So for finding adjoint, I will write down here the result. How to approach? If we are approaching this one, we need to repeat first two columns and then first two row. We will not take first column and first row. The remaining whatever we are having, we will take the all 2 cross 2 minors here. So when I will go with the very first 2 cross 2 minor, it will be 2 1 ja 2 minus minus plus 3. So 2 plus 3 is 5. So my very first element will be 5 here, beta. My very first element will be 5 here. So when I will go with this one, it will be 5. So it will be 5. The very first element is 5. Let's find out. I need to find out first row, top row. So if I will go only with the first columns minor, then also it will give me the right answer. There is no need to go with complete. So if I will go with this one, minus 3 and 0, so it will be minus 3 and 0, so it will be minus 3. When I will go with the next one, this is 0 minus minus plus 1, it will be plus 1. So if you will follow my process, if you will follow this smart technique, then there is no need to find all the minus even. We can directly approach it. We can solve it very, very easily. Okay, as it is asking about top row, we know very well by this method how to solve. If I'm solving here the first minor row wise, I need to write down the result in the adjoint matrix column wise. So if the question is asking me about the first row, then I will not find out every minor. I will only find out the minors of first column. So this is first one, first minor, second minor and third minor. So when I will solve these three minors of first column, these will be the elements of first row of adjoint matrix, which is 5 minus 3 and 1. Which is 5 minus 3 and 1. So I can see my result is 5 minus 3 and 1. Now you can ask, or one question can arise in your mind, ki ma'am, what about the determinant? Beta, here you can see in the options exactly the thing which we get, as here 5 minus 3 1 is coming in the option B. So it will be my answer here, but the determinant is 1. That's why it is not showing. Suppose in this case, suppose we are taking another example, and in that case your determinant is 2. You need to consider that determinant. Either you will write down the determinant outside the matrix, or you will include the determinant inside this one. So right now the determinant is 1. That's why it is 5 minus 3 1 only written. So here it is not mentioned, only 1 is there. Clear, bachcho? Isn't it? Yes. Okay, very good, shabash. So I hope this is clear to everyone. I am not able to see now. It is clear. Yes, so there is no need to go for the options. You can directly go with this one. Okay, if you want to find out the determinant, you can check the determinant. When you will solve it, determinant is with respect to 1 minus 2 minus minus plus 3, 0 is 0. Minus 1, it is 3 2 ja 6 minus 2. So when I will solve, this will be 5 minus 4, which is 1. So my determinant is actually 1. That's why I am not using it. That's why I am not considering it. I am writing directly. Okay. So there is no need to check option. Why option check? There is no need to check option, beta. Why we need to check the option? We can directly approach it. Directly we can approach it. Clear? Alright. Now let's go. I hope this one is clear to everyone. Let's go to the next one, which is today's heading, is linear system of equation. Let's learn the concept first of all, what is linear system of equation, which type of system of equation we are having, how to approach system of equation. Then we will talk about more here. So here in the GATE exam syllabus in engineering mathematics, we are having linear system of equations of two type, homogeneous system of equation and non-homogeneous. This topic is one of the most important topic in linear algebra. If I will say there are three segments in linear algebra, in first segment, which is matrix algebra, we can expect the question, or if I talk about the most expected concept, that is determinant and inverse. When we come to the second concept, which is rank of matrix, so here before approaching to the rank of matrix, you should know about the system of equation, because it's not randomly, but I will not say every year, but yes, we can say that most of the time we can see the question from system of equation including rank also, right? So this is second important topic. And the third one, when we talk about the next one, means system of equation plus rank is there. And third segment or third concept which is important in linear algebra is eigenvalues, eigenvector. So in this one, these three are important and you should not miss any one of them. Chalo, let's start with the linear system of equation. As in our syllabus, we are having two type of system of equation, homogeneous and non-homogeneous. Before approaching to that one, we should understand, beta, what is before approaching to that one, we should understand what is consistency and inconsistency. We should understand what is consistency and what is inconsistency. Bachcho, tell me, do you know about what is consistency? Do you know about what is consistency? Tell me, bachcho. Yes, guys, tell me, is there any lag? Is there any lag? Let me check. Is there any lag? Yes. Okay, now it is okay. Yeah, I can see what at least one solution. You are saying about consistency. Okay, continuously one solution. Okay, now what is the meaning of consistency, beta? The meaning of consistency, let's talk in a very simple language. Any system of equation is said to be consistent if it has at least one solution. Means if for any system of equation, whether it is homogeneous or non-homogeneous, if I can get at least one solution, then I can say yes, that system of equation is called consistency. But as you said that the meaning of consistency is continuously, beta, the continuously is actually the meaning of the word. It's not in the engineering mathematics or here in this system of equation. So consistency, you can write down here any system of equation is said to be consistent, because this is very important. You need to be understand this one. Is said to be consistent if it has at least one solution. If it has at least one solution. So I'm saying कि my system of equation is said to be consistent if it has minimum one solution. Suppose any system of equation is having zero solution. Suppose if any system of equation is having zero solution, then that system of equation is said to be inconsistent, beta. So in that case, we will say that that system of equation is nothing but inconsistent. So this is important part. Any system will said to be consistent if it has at least or minimum one solution. If it has no solution or zero solution, that will called as a inconsistent. All right. Now let's come to the system of equation. If we talk about the normal or the linear system of equation, Ax is equals to b. Okay, how I'm writing Ax is equals to b, that you should understand. If I'm having a system equation like this one, a1 x b1y c1z is equals to d1, a2x b2y c2z is equals to d2, or a3x b3y c3z is equals to d3. Here I am having, this is my system of equation which is linear. If I will write down this system of equation in the form of matrix, so this a1, a2, a3, we will consider here a1, b1, c1, a2, b2, c2, a3, b3, c3. These a1, a2, a3, b1, b2, b3, c1, c2, c3, we will consider in a matrix A, which is called the coefficient matrix, because ultimately a1, a2, a3, b1, b2, b3, c1, c2, c3 are respectively coefficients of x, y and z. So this is called the coefficient matrix, right? If I want to write down from here the variable matrix means capital X I want to write down, which will be nothing but XYZ transpose. Okay. And if I want to write down here the constant matrix, the constants are D1, D2, D3. Okay. So this will be constant matrix D1, D2, D3. Alright. If you want to write down this as a B, capital B. So the combination A, X and B togetherly, if I will write down, this will be Ax is equals to B, and this is called the system of equation. If we are having here linear power, so this will be a linear system of equation. This will be a linear system of equation, beta, right? So here this linear system of equation, about this one we will talk everything. This A is called the coefficient matrix. This X is called as a variable matrix. This B is called as a constant matrix. Okay. So here if I am saying कि if I am having Ax is equals to B, this is my system of equation. System of equation or the linear system of equation has a two type of equation. First is the homogeneous system of equation. Homogeneous system of equation. And second is called the non-homogeneous system of equation. Homogeneous system of equation, and second is called the non-homogeneous system of equation. Clear? हाँ, X मैट्रिक्स ट्रांसवर्स इक्वेशन का XYZ वैल्यू है. No. X matrix, the transpose because XYZ will be like this only. XYZ will be a row matrix. I just write down here a column matrix, that's why. Okay. Now look at here. What I am saying, this is homogeneous system of equation and non-homogeneous system of equation. How we can identify whether a system of equation is homogeneous or non-homogeneous? Only with one important rule or one important tool, that is this B. If this B is nothing but the constant matrix, na, right? So if this B is equals to 0, it will be a homogeneous system of equation. If this b is not equals to 0, this will be a non-homogeneous system of equation. So here you can write down, in homogeneous system of equation we are having Ax is equals to 0, means the constant matrix db, which we are writing d1 d2 d3 is 0. And if here Ax is equals to b, this is called the non-homogeneous system of equation, beta. Now here we will talk about in detail what is homogeneous system of equation, what is non-homogeneous system of equation, how to solve, okay, which type of solution we are having, how to find the solution, everything here we will discuss. So let's start from the homogeneous system of equation. So here we are going with the homogeneous system of equation. Homogeneous system of equation. Bachcho, when we talk about the homogeneous system of equation, now I can say, as I told you, this Ax is equals to 0 is said to be homogeneous system of equation. One simple question, beta, if I will ask you, will you tell me, if I am writing here 7x is equals to 0, if I am writing here 7x is equals to 0, what is the meaning of this 7x is equals to 0? Will you tell me what is the meaning of this 7x is equals to 0? Isn't it, beta? 7x is equals to 0 means x is equals to 0, yes. So can I say कि when I am writing 7x is equals to 0, for this equation x is equals to 0 is a solution always? Yes, definitely. Arey, this is the concept of class 7th or 8th, na? We know very well. If I am writing somewhere 7x or ax or 5x or nx is equals to 0, it means my x is always is equals to 0. So when x is always is equals to 0, it means I can say na, ki when I will put x is equals to 0 here, it will be same, LHS is equals to RHS. So we can say that this x is equals to 0 is a solution, is always a solution of this equation. Yes, definitely. Now the same thing if I will ask you here, beta, if I am having ax is equals to 0, can I say x is equals to 0 is always a solution for this equation? Yes, definitely. Is x is, if x means here x is equals to 0 is always a solution of this equation? Yes, 100%. If x is equals to 0 is always a solution for this equation, then can I say, with the define of consistency and inconsistency, can I say if x is equals to 0 is always a solution of this equation, then my homogeneous system of equation, beta, my homogeneous system of equation will always a consistent? Yes, surely, 100% we can say, because what is my condition? If in any system of equation we are having at least one solution, then that system of equation is said to be consistent always. So here I can say that x is equals to 0 is always a solution of this system of equation. Yes. So this is means homogeneous system of equation is always consistent. Homogeneous system of equation is always consistent, because it is having always, whether it is more or not we are having, but x is equals to 0 is always a solution. So is always consistent. This thing we can understand very easily. Yes, exactly, is one solution. Okay, now if I am saying that x is equals to 0 is a solution, bachcho, then this x is equals to 0 is said to be the name of this one, this x is equals to 0, which we are saying a solution. This x is equals to 0 is said to be unique solution also. Let it be later. This has said to be as 0 solution. This said to be as a 0 solution in some books. We can say this as a null solution also. Okay. We can say this one as a trivial solution also. 0 solution, null solution, trivial solution. Even in some books you can see this is the unique solution. Sometime it will work as a unique solution also. So this x is equals to 0 is called as a zero solution, null solution, unique solution, or trivial solution. The word trivial is very important. Okay, here the word trivial is very important. We need to be careful here with this word trivial. Okay ji. Now this is clear. What about this one? So one more question can arise in your mind ki ma'am, if the system of equation is homogeneous, then do we have only x is equals to 0 as a solution, which we are saying as a zero solution, null solution, trivial solution, or sometime unique solution? No. No. We are having here more type of solution. How to identify those? Let's approach it. So if for this you need to find out the rank. Okay. For this you need to find out the rank of any matrix. So if you know how to find out the rank of matrix, then only you can approach it. Okay. So here I will show you how to find the rank. As I told you, here only in the system of equation only we will talk about the rank of matrix. Clear? Okay. So here if rank of any matrix A is equals to number of unknowns. Number of unknowns. Meaning of number of unknowns is number of unknowns. Number of unknown means number of variables. Variables means x, y, z here. Number of unknowns or number of variables. If the rank of any matrix is equals to number of unknowns or number of variable, then we will say in this case we are having always a unique solution. In this case we are having always a unique solution. Okay. So other than this we can have this type of solution also. Suppose you find out the rank of any matrix and that rank is less than to number of unknowns or number of variables. If your rank is less than to number of unknowns or number of variables, then in that case your system will have, in that case your system means the homogeneous system of equation will have infinite solution. Will have infinite solution. Okay. Now one thing which you need to understand here beta, one thing, be careful with that one. As before approaching to this one, I will show you, I will definitely tell you about the rank, how to find out the rank. I will tell you here the basic rule about how to find out the rank, I will tell you. But before approaching here, as suppose I am having a matrix. Suppose I am having a matrix 1, 2, 3. Okay, let's write down here before that, because now I need here the determinant only. So for that we need to understand the rank. So let's talk about in few words as a rank of matrix. What is rank of matrix? Why we are finding rank? For getting which type of solution our system of equation is having. So if I need to check whether my given system of equation having unique solution, infinitely many solution, or no solution, whatever the solution it is having, we need to identify rank. So that's why in system of equation only we will consider the rank of matrix here. So what is rank of matrix? Rank is denoted by row first of all. Okay. Why we are finding rank? For checking any system of equation having solution or not. Suppose you are having a matrix A. Bachcho, try to understand my point. Suppose you are having a matrix A which is M cross N matrix. Which is a M cross N matrix means the number of rows and number of columns are given to you. And if you need to find out the rank of this matrix M cross N, then you will write down always it is minimum of Mn. You will write down the rank of any matrix A is less than is equals to minimum of Mn. Rank of any matrix A is less than is equals to minimum of Mn. Okay. Now try to understand what is the meaning of minimum of Mn. I am giving one example here beta. Suppose I am having a matrix 1, 2, 3, 4, 1, 2. Suppose I am having a matrix whose order is, what is the order of this one? You can see we are having 2 rows and 3 columns. So this is a 2 cross 3 matrix. As you said ma'am, if a matrix is a M cross N matrix means a rectangular matrix. We need to find out the rank of this one. Then we will write down now कि rank of this matrix will be less than is equals to minimum of Mn. So minimum of Mn means here I am having 2 and 3, minimum of these two. Minimum of Mn. So what is minimum between 2 and 3? You will say, remember minimum is 2 only. So we will write down here the rank of this matrix A will be less than is equals to 2 because the minimum number is 2 only. Now from here how I will identify whether my rank is equals to or my rank is less than 2. Whether the value of my rank is equals to or it is less than 2. How we can identify? Let's approach it. So for that we need to go for the determinant. So that's why here everything is interconnected. You need to identify, you need to approach the determinant for finding rank. You need to know how to find the rank before approaching the system of equation. Right here. So if I will go with the determinant, I will check the determinant means what you will do. If I am having here rank of matrix A is less than is equals to 2. The number is written here 2. What you will do in the given matrix, you will check the minors of 2 cross 2 one by one. In the given matrix, बच्चों, you will check the minors of 2 cross 2 one by one. Okay. When you will check this very first minor, suppose the value of this very first minor is not equals to 0. It is not equals to 0, then you will not proceed to the next minor. But if the very first minor is equals to 0, then you will check the next minor, which is this one. Suppose this is also is equals to 0, then you will check the next minor, which is this one and this one. You will include first and last column. Right? So if very first minor is not equals to 0, then we will conclude there only. If my very first minor is equals to 0, I need to check the remaining or the available minors also. Clear? So if I am saying here the rank of A is less than is equals to 2, I need to check the very first minor of this matrix. When I will check the very first minor of 2 cross 2 here, I can say this is 1 minus 8 beta, which is minus 7. Whatever it is not equals to 0. Whatever it is not equals to 0. One for sure, yes. So when it is not equals to 0, I can conclude here my motive is only whether the value of minor is 0 or non-zero. It is positive, negative, whatever it is, it does not make any difference. Only one thing makes difference, whether it is 0 or non-zero. So here I am having non-zero. So then if the very first minor is not equals to 0, then you will say for this particular matrix, rank will be equals to. Your rank will be equals to. Okay. Suppose this is the first case. Suppose in this case, if we are having a matrix like this one, 1, 2, 3, 4, 1, 2, 3, 4, 8, and suppose it is 3. If we are having a question like this one, then I can see if I will find out the very first minor beta, this is 4, 1 into 8 is 8, 8 minus 8, 0. Then I will not conclude instantly that my rank is equals to 2 or less than 2. When my very first minor is equals to 0, I will check the second minor. If I will check the second minor, I can see this is 6 minus 24, whatever it is not equals to 0. Suppose your next minor is also 0. Suppose your next minor is also 0. When you will check here 24 minus 24, this is 0. First is 0, second is 0, then definitely the remaining 12 and minus 12, it is also 0. So when your all minors are 0, for this specific matrix, all the minors of 2 cross 2 are 0, then you will say your rank will be less than 2. Your rank will be less than 2. Right? Yeah. In this case, your rank is less than 2. If at least one minor is not equals to 0, then you will say your rank is equals to 2 here. Acha, one more thing, when we are talking about less than 2, we are having option as 1 also, we are having option as 0 also. So one point you will write down as a key note. 1 point बच्चों you will write down as a keynote that minimum rank of any non-zero matrix, minimum rank of any non-zero matrix is always 1. It is not 0. If your matrix is a non-zero matrix, then its rank will not be 0. Yes, if a matrix is a null matrix or a zero matrix, then in which all the elements are 0, then the rank will be 0, okay. But if a matrix is a non-zero matrix, then its minimum rank will be 1 always. So minimum rank of any non-zero matrix, minimum rank of any non-zero matrix is always 1. Clear? Is always 1. So you need to be careful. So when we are saying the rank of A is less than 2, so less than 2 means 0 will be not possible here, only 1 will be there. Only 1 will be possible. If it is not 2, then it will be 100%. Clear? So in this way we can find out the rank of any matrix, basic matrix. Clear? One more key rule you can write down here. If we are finding the rank, then rank of matrix A is always is equals to rank of A transpose, okay, and even it is equals to A into A transpose also. Rank, because rank will not change by changing rows or columns. So column and row transpose does not make any difference in rank. Okay bachcho? So if you will just write down these basic things now, then you can easily approach the system of equation here. Alright, so I hope the rank is clear to you. Now let's come to here this question again, this concept again. What we are asking, we were discussing about the homogeneous system of equation. So the homogeneous system of equation is here, if in a matrix, if in a homogeneous system of equation, rank of any matrix is equal to number of unknowns, okay, then you will say that system of equation will having the unique solution. If, okay, and the system is consistent because this is a homogeneous system of equation. If in any matrix, if any system of equation which is homogeneous, rank of A is less than 2 number of unknowns or variables, then you will say in this case you are having infinite solution. One basic thing you need to understand, when we are saying, suppose I am having a n cross n matrix, bachcho, try to understand my point, this is very very important. Okay, just try to understand my point here. If we are having a n cross n matrix and the determinant of this n cross n matrix is 0. If the determinant of this n cross n matrix is 0, then you will say the rank will be less than n. Rank will be less than n when the determinant of n cross n is 0. If the determinant is not equals to 0, if the determinant is not equals to 0, then you will say the rank will be n. Rank will be n. Okay. This is called the relation between rank and determinant, which we should understand before approaching the system of equation. So rank of any matrix, if we are having, suppose I am having a matrix whose order is 3 cross 3 and I am saying the determinant of this one is 0, then surely my rank will be less than 3. If I am saying the determinant is not equals to 0, then surely my rank will be equals to 3. Clear bachcho? So here I can see, as if I am saying my system of equation having a unique solution. If my system of equation having a unique solution, it means rank is equal to number of unknowns, and number of unknowns are usually x, y, z only. If in this case we are saying, then this is, in this case you will write down the determinant, if the rank is equal to number of unknowns, right? Rank is equal to number of unknowns, then you will say in this case, suppose I am taking example of this one, ki 3 cross 3 is my matrix and I am saying ki 3 cross 3 means the rank is equals to 3. So in this case the determinant is not equals to 0. If I am saying for a 3 cross 3 matrix beta, the rank is equals to 3, then 100% determinant is not equals to 0, because if determinant is equals to 0, then this minor will be 0. We need to go for the next one less than to this one. So it is not possible here. So we will write down for the unique solution determinant is not equals to 0. For the unique solution determinant is not equals to 0 means the name of unique solution is trivial solution also. So you can use this condition for the trivial solution determinant is not equals to 0. But if I am saying about the infinite solution, the other name of infinite solution is non-trivial solution. The other name of this one is non-trivial solution, and for the non-trivial solution, determinant of given matrix is always is equals to 0. You can check. Again with one example, ki suppose I am having a matrix A whose order is 3 cross 3 and I am saying the determinant is equals to 0. If the determinant is equals to 0, I will write down my rank is less than 3. And if the order is 3 cross 3, it means we are having 3 unknowns or 3 variables here. So if the order is 3 cross 3, my rank will be less than 3. My rank will be beta less than 3. So when the rank is less than 3, okay, it will be less than to number of unknowns. So here we can see the determinant is 0. So it will be in the case of infinite solution. So for homogeneous system of equation, if you are asking about the infinite solution or non-trivial solution, the determinant will always 0. The determinant will always 0. You need to be careful because one GATE question has been asked directly based on the non-trivial solution. If the solution is non-trivial, then the determinant is equals to 0. If the solution is trivial, then determinant is not equals to 0. Clear बच्चों? Okay, now let's come to the next thing. Okay, here we need to check for this system of equation which I can see as a homogeneous because this is A, this is x and 0, Ax is equals to 0. So for this system of equation, I need to check whether we are having no solution, only one solution, non-zero unique solution or multiple solution. You guys will check. You guys will check here and tell me what solution we are having here. Can you find out the rank and tell me? Yes, bachcho, tell me what it is. Whether we are having no solution, only one solution, non-zero unique solution or multiple solution. Yes. Is it B? Okay. Abhishek and one more guy. I don't know what's your name. Write down your name. It's too lengthy to name again and again. Okay. So is it B? Let's check it out. How to write down, how to approach it. So we can see first of all This is a homogeneous system of equation Ax is equals to 0. I need to check whether it is having unique solution, no solution, non-zero unique solution, multiple solution, or only one solution. So what we need to do, we will check here, we will find out the rank of this matrix A. So matrix A is a 2, minus 2, 1 and minus 1. So for finding rank, I need to go for the determinant, right? As the matrix is a 2 cross 2 matrix, I will find out the value of this determinant. So I can say this is minus 2 minus minus plus 2, which is 0. So if the determinant is equals to 0, it means I can surely say the rank is less than 2. Because the determinant is 0 here. So if the determinant is 0, means my rank of this matrix is less than 2. Less than 2 means here we are having, less than 2 means here we are having what, bacho? Here we are having how many unknowns? 2 unknowns, x1 and x2. So here we are having how many unknowns? 2 unknowns. So this is less than 2 number of unknowns. So when it is less than 2 number of unknowns, you can say here we are having infinite solution. Here we are having infinite solution. Now you need to understand one more point, because here the multiple solution option is also there. Multiple solution option is also there, and you are saying that this is only one solution, x1, x2, 0, 0. So you are saying means we are having only x is equals to 0 as a solution. Abhishek Kumar, is it? We are having only x is equals to 0 as a solution here. For finding the solution of any system of equation, you need to check here the rank. Means for rank means you need to check the determinant, whether the determinant is 0 or not. We need to check what is the rank. So if I will check the rank 2 minus 2, 1 minus 1, this is minus 2 minus minus plus 2. I am having this quantity as 0. So the determinant is 0, means rank is less than to 2. So here less than to number of unknowns means the system is having infinitely many solutions. Yes, the system is infinitely many solution. So we had a discussion now कि when the rank is less than to 2 or number of unknowns, it will have infinitely many solution, isn't it? When rank is less than to number of unknowns, and number of unknowns are here only 2, x1 and x2. Okay. So I am getting right now the multiple solution or infinitely many solutions. But suppose you want to, suppose they just give you here the no solution is not possible, non-zero unique solution is also not possible. It is mentioned only one solution. It is mentioned only one solution. It means we are having only x is equals to 0 as a solution. So no, this is not right. We are not having x is equals to 0 as a solution here. Only x is equals to 0 is not a solution. One of the solution is this one, but it is mentioned now only one solution. No. If it is mentioned one of the solution is x1, x2 is equal to 0, 0, then yes, we will be agree, because we are having an infinite solution or the multiple solution. So this option is not right first of all. Option B, because the determinant is 0. If the determinant is 0, it means the rank is less than 2 number of unknowns. If the rank is less than 2 number of unknowns, means here we are having 2 unknowns. So the rank is less than 2 unknown means infinitely many solution. So here if we are having infinitely many solution, then multiple solution will be the correct answer. But here if it is not mentioned, if it is written one of the solution is x1, x2 is equals to 0, 0, then also it is right. So in this case my question become MSQ. This one will be right and this one will be right. But right now we are having here mentioned as only one solution. So beta only one solution is not possible here. Only x is equals to 0 is not a solution. We are having other than that also the solution. Clear? One thing. Second thing, suppose you need to identify how many solutions you are having. So you can identify by number of linearly independent solutions. Number of linearly independent solution, which is written by P equals to n minus r. P equals to n minus r, where P is the number of linearly independent solution, n is number of unknowns or order of the matrix, unknowns or variable or order of the matrix, r is rank of matrix. Bachcho, in the last question, can you tell me what is the rank of this matrix A? In this last question, bachcho, will you tell me what is the rank of this matrix A? Can you see here the rank of this matrix is actually 1 here. Ma'am, the determinant is 0, so rank is less than 2. Less than 2, it means the rank is 1 here. So rank is 1, right? If I need to find out here number of linearly independent solution, I will use this formula. P is equals to N. Number of unknowns are 2. Yes. Rank is 1. So 2 minus 1, 1. So here I will say, other than this x is equals to 0, we are having one more solution. If it is given to me one solution, 2 solution, 3 solution, means multiple, so we should write down now. So 1 solution, 2 solution, 3 solution, 10 solution, 11 solution, whatever it is, we can count the number of solution by using this formula. We can count the number of solution by using this formula, which is P is equals to N minus R, which has been asked in GATE exam also. Very easily you can count. Okay. Here I can see in the option it is mentioned only one solution. That's why it is not possible. This is also not possible. Non-zero unique solution is also not possible, because we are having here multiple solution. Clear? Okay. Now let's come to the one very good question, which is again a GATE problem, and it will give you more clarity about the travel and non-travel. So let's read this one. Consider a matrix A, which is k, 2k, k square minus k and k square, and vector x, which is x1, x2. Then the number of distinct real values of k for which the equation ax is equals to 0 has infinitely many solutions. Now in this case, it is already given to you, beta, we are having infinitely many solutions. Okay, so it means it is already given to you, your rank is less than 2. Let's approach it. You guys will try, then I will tell you how to deal. Take your time. A good question, a very good question. यस बच्चों, यस गाइस टेल मी. Okay, let's approach it. So here, what is the answer? First of all, as I told you beta, if you want to go with these type of question, only one thing which you need to follow to understand the language. In the language only everything is given to you. Let's read out again. The matrix is given to me, okay. One vector is given to me, okay. It is given to me distinct real values. We need to find out number of distinct value. It is not asking the values of k. It is not asking the value of k. It is asking about the number of distinct value. How many values of k are possible? Okay, which has the equation infinitely many solution. Now, do you understand what is the meaning of infinitely many solution? First of all, do you understand what is the meaning of infinitely many solution? Infinitely many solution means if in system is a homogeneous system of equation. So in this case, infinitely many solution means ma'am rank is less than 2 number of unknowns. If the number of unknowns are n. Or I can say if the system is having infinitely many solution, it means the determinant will be 0 because this is called the non-trivial solution. Because this is called the non-trivial solution, na? So the determinant will be 0. Huh? The determinant will be 0 in this case? Yes, surely. So what we will do? We are having Ax is equals to 0 as a system of equation means homogeneous. So I will take first of all the matrix A, which is k, 2k, k square, k, 2k, k square minus k, k square. This is, and this I need to put equals to 0 because it is already given to me. My system is a infinite number of solution, means it is having a non-trivial solution, right? So when we will solve, we can say this is k cube minus 2k into k square minus k equals to 0. When we will solve, it is k cube minus 2k cube plus 2k square is equals to 0. Huh. Again when we will solve it, we can see from here it is 2k square minus k cube is equals to 0. I can take k square outside. It will be k square when I will take outside. It will be 2 minus k equals to 0. So it is giving me the values of k. When I will put it equals to 0, I am having here k square. So k is equals to 0 and 0. And once I will put it equals to 0, I am having k is equals to 2. So if the question is asking about what are the values of k, then I will write down the values of k are 0, 0 and 2. If it is asking about number of values of k, then I can see how many values I am having. 0, 0 and 2 means I am having 3 values. If it is asking about only how many values of k are possible when the system is having infinitely many solution, then my result will be k will have 3 values, 0, 0 and 2. But the question is asking about how many distinct, this word is very, very important beta here. Distinct means different, separate. So how many distinct real values are possible here? So that we can say, ma'am, 0 and 0 to repeated. So if I will write down the distinct values, it will be 0 and 2. How many distinct value we are having? We are having only 2 distinct value. Which one? 0 and 2. So my result will be how many distinct values we are having? We are having 2 distinct values. We are having 2 distinct values. Is it clear, प्यारे बच्चों? Is it clear, प्यारे बच्चों? Yes? Okay. Now I hope this is clear. Please confirm. Clear? Okay. Chalo. Now, let's talk about these three words, which is dimension, basis and nullity. Do you know about dimension? What is dimension? What is basis? What is nullity? Bacho, I cannot see the comments. Yes. Do you know about these things? Yeah. Okay. Let's approach it. Let's approach it. Come. Now, what I am asking, do you know about dimension, basis and nullity? Let's approach. What is dimension? Dimension is number of linearly independent solutions or linearly independent vectors in any matrix or in any system of equation. Linearly independent solutions or vectors. Okay. Basis is set of linearly independent vectors. Set of these linearly independent vectors is called the basis. And nullity is also same. Nullity is the number of non-zero rows or the number of linearly independent. So nullity is also equals to the number of linearly independent vectors. Clear? Here you should know, bacho. Here you should know, as it is asking about the dimension of the null space of this matrix. So we need to find out here dimension. Dimension means I need to check how many linearly independent vectors are there. How many linearly independent vectors are there? For finding this one, I give you this now. For finding nullity, we can use P is equals to N minus R. So from this we can find out the number of linearly independent vectors. We can find out number of linearly independent solutions, right? So from this we can use P is equals to N minus R. We can find out the nullity or the dimension of null space also. So nullity and these two are same. Basis is set. If I am having suppose 10 linearly independent vector, and if I will just manage, if I will write down those 10 vectors as a set, so that set is called as a basis. Okay, that set is called as a basis. So suppose if I am having x1, x2, x3 as linearly independent vectors, so this will be my, if I am talking about the dimension, so number of linearly independent vectors, so it is 3. If I am talking about nullity again the number of linearly independent vectors or non-zero rows, so that is also 3. Nullity is also 3 here. If I am talking about basis, so basis will be the set. So set will be x1, x2 and x3. This will be the set basis. This will be the set basis. Okay, now let's come to this one. Find the dimension. Dimension means number of linearly independent vectors of this null space. So for finding dimension, I need to use P is equals to n minus r. So for using P is equals to n minus r, I should know n. N is the number of unknowns or order of this matrix. Second is r. R means the rank of this matrix. So I need to identify r here. As we can see, the order of the matrix is 3 cross 3. So n is equals to the 3 here. Let's go for the rank of this matrix. So if I will find out the rank, then I can approach it. What will be the rank? For finding rank, we will go for the determinant of this matrix, which is 0, 1, 1. Next is 1, minus 1, 0. Next is minus 1, 0 and minus 1. I need to check the value of this determinant. I need to check the value of this determinant here. So how to find out the value of this determinant? We will solve here. As the order is 3 cross 3, we will check whether the rank is less than equals to 3 or equals 3. So we will go for the determinant. So when I will go 0 with respect to 0, it is 0. Minus 1, it will be minus 1 and 0. Plus 1, it will be 0, minus minus plus, again minus 1. So it will be minus minus plus 1 and minus 1. I am having the determinant is equals to 0. I am having bachcho the determinant is equals to 0 here, isn't it? Please confirm. Yes, ma'am. The determinant is 0. When I will solve with respect to 0, it is 0. When I will solve with respect to minus 1, it is minus 1 plus 0. When I will solve with respect to this one, it will be 0, minus minus plus and again minus 1. So this will be minus 1, this will be minus minus plus 1, I am having 0. When the determinant is 0, I will go for the rank is less than 3. For less than 3, if you are having a 3 cross 3 matrix, if your determinant of 3 cross 3 is 0, you will check the minor of 2 cross 2 in this case. So when I will check the very first minor of 2 cross 2 beta, here the very first minor is not equals to 0. So I can conclude my rank is equals to 2 here. Rank is 2. I need to find out here the nullity. So P is equals to 3 minus 2. The number of unknowns are 3. Okay, rank is 2. So here we are having one linearly independent solution. One linearly independent solution or one linearly independent vector. So my answer will be option B for Bombay here. My answer in this case will be option B for Bombay. Bachcho, please confirm. Clear? Clear everyone? Yes. Okay. Now let's talk about the next one. This formula which we already had a discussion, this has been asked in the GATE exam. Let A be n cross n matrix with rank of R, where R is lying between 0 to 1. Then Ax is equals to 0, has P independent solutions, where P is n minus R. Where P is n minus R. Where your P is n minus R. Where P is equals to n minus R. We know this formula. Now let's talk about the non-homogeneous system of equation. Okay. For this we will talk about the basics, the concepts and the questions related to this one we will talk in the tomorrow session. Okay, so let's talk about first of all the non-homogeneous system of equation. Non-homogeneous system of equation, it means we are having Ax is equals to B type of system of equation, where the coefficient matrix means D1, D2, D3, this matrix is not equals to 0. Okay. If we need to find out the solution, which type of solution the non-homogeneous system of equation have, So we need to check here again the rank. As if I will say from here I am having matrix A and one more matrix is there, AB. This AB is called the augmented matrix. Bachcho, this AB is called the augmented matrix when we are combining two matrices together for finding the rank. So this is called the augmented matrix AB. Okay. The class duration is 1.5. The class duration is 1.5 from 7 to 8:30 it is. Okay, so here we can see the augmented matrix. Let's approach it. How to find out the system of equation, which is a non-homogeneous system of equation, which type of solution it is having, whether it is having a unique solution, infinitely many solution, or what type of solution. So let's approach it. Here everything, just like in the homogeneous system of equation, everything depends on the rank of matrix A only. But here in this case, everything depends on the rank of matrix A and rank of matrix AB. On these two, everything depends on the rank of matrix A and augmented matrix AB rank. Okay. So let's talk about here what are the cases or the non-homogeneous, means Ax is equals to B. How to identify the solution? The first step is you will find out the rank of matrix A, right? So if rank of matrix A equals to rank of matrix AB, and if it is equals to number of unknowns, means number of variables. If in non-homogeneous system of equation, rank of matrix A equals to rank of matrix AB equals to number of unknowns, then we will say the system will be consistent. System is consistent. Okay, and it will have unique solution. System is said to be consistent and having unique solution. Why my system is consistent? Because in this case we are having minimum one solution. Here we are having exactly one solution, which is called the unique solution. So one solution is there. If in any system of equation we are having minimum one solution, then that system of equation is said to be unique solution. Sorry, that system of equation is said to be consistent. So here when we are having unique solution, my system of equation is said to be consistent. When the unique solution is possible, if rank of A equals to rank of AB equals to number of unknowns. Clear? Suppose in the second case, if rank of matrix A equals to rank of matrix AB, but it is less than 2 number of unknowns. But if it is less than 2 number of unknowns beta, then in this case my system will have infinitely many solution, or we can say this is more than one solution, okay, and system will be consistent because it is having at least one solution again, so system will be consistent. Okay, if rank of matrix A equals to rank of AB, but it is less than 2 number of unknowns, then in this case we will go with the infinitely many solution or more than one solution or infinite solution. Okay, and your system is said to be consistent. Your system is said to be consistent. Suppose in the next case, if rank of matrix A is not equals to rank of matrix AB, if in the next case rank of matrix A is not equals to rank of matrix AB, then you will say it will having no solution and system is said to be inconsistent, and system is inconsistent because there is no solution. Why inconsistent? Because the condition of consistency is system should have minimum one solution. When it is not having any solution, then your system will be inconsistent. Your system will be inconsistent. So here we are having, when we are having here no solution, the system is inconsistent. Clear? Okay. Chalo. So I hope these three things are clear to everyone, because according to this one we can approach how to deal with the system of equation, how to deal with the non-homogeneous system of equation, when your system is having unique solution, when your system is having infinitely many solution, when your system is having no solution. Okay, that you can better understand from this one. Now, as everything I told about these things only, as here we can go with the questions. Okay, so for approaching the question, we will talk in the next session. Tomorrow we will start from the questions only, and then we will continue with the next topic also. Okay, so tomorrow we will discuss the questions. We are having so many questions here, and then we will talk about the next topic also. Clear, guys? I hope this is clear to everyone. So if you are watching the lectures in the live, you should reply. You should share the link of this session with all of your friends, because on Tuesday and Wednesday we are having most expected concept series of engineering mathematics at 7 to 8:30. On Saturday, Sunday 9 to 10. Saturday, Sunday 9 to 10 we are having a series of means I will say excellent. These are the best questions. Okay, so excellent practice questions for general aptitude. So you should not miss these two series, which are absolutely free to all students. You can share the link of each and every session with each and every Telegram group, so that more students can join with us. Okay. Okay, so we will discuss from this one in the next series. Next means next session, so tomorrow. Question कहाँ से मिलेगा? What you are saying? Question यही मिलेगा. Okay. Most that series is a different excellent practice question of general aptitude, which is going on Saturday, Sunday 9 to 10, and this is most expected concept series, in which we are discussing concept plus questions also. So this one is dedicated on Tuesday and Wednesday 7 to 8:30. Clear? Okay, so I hope whatever we discuss here, everything is clear to everyone. We will start tomorrow session from this question only, and then we will discuss about the more things. Okay. PPT, I will not share the PPT. I will share the PDF of this one with in our IMS GATE Academy Telegram group only. So if you are not joined in our IMS GATE Academy Telegram group, you can join. Yes, Telegram only. Okay, chalo. So that's all from this session. Bachcho, see you tomorrow again at 7 o'clock. Till that, take care. Bye bye.